Hey everyone, have you ever asked an AI coding assistant for what you thought was a simple change, only to watch it completely torch your entire application? Yeah, we've all been there. Well, today, we're looking at a tool called Git Nexus that's designed to fix that. It literally gives your AI a map of your code so it can finally see the whole picture.
It's a really good question, right? We have these incredibly powerful, world-class AI models, and yet they can still introduce breaking changes without even realizing it. So why does this keep happening? Well, it all comes down to one single critical thing: a massive blind spot. So here's our game plan for today. First, we're going to dig into that AI coding blind spot. Then, we'll introduce Git Nexus as the solution. We'll look at how it actually builds its knowledge, check out the two main ways you can use it, and then wrap it all up with why this is such a big deal.
Okay, so let's tackle the main problem head-on. Even with the best AI tools out there, there's this kind of hidden danger lurking in AI-assisted development, and it stems from this one critical blind spot.
Picture this. You ask an AI to edit one little function, and it does a great job. The code it writes is perfect for that one function. But what it doesn't see, what it can't see, is that there are, say, 47 other functions scattered across your codebase that depend on that original function. And the result? Those breaking changes get committed, they get shipped, and suddenly everything's on fire.
So what's the fix? What if we could just give that AI a complete, detailed map of our entire codebase? Well, that is exactly what Git Nexus is designed to do. Think of it this way. They're trying to build for AI agents what Git built for version control, a really deep structural understanding of the code.
So what is it, really? At its core, Git Nexus is a client-side engine. And that's important. It means it runs right on your machine, so your code stays local. What it does is it scans your codebase and turns it into this incredibly detailed knowledge graph. And that graph is what gives the AI agent the architectural awareness it's missing. It can finally see all the dependencies and connections it was blind to before.
I love this quote from the creators because it puts it so perfectly. You might have tools that help an AI understand the purpose of code by looking at comments and documentation. That's kind of like a wiki. But Git Nexus goes deeper. It's not just about understanding, it's about analyzing, because that knowledge graph tracks every single structural relationship in the code.
So how in the world does it build this incredible map? Well, the secret sauce isn't just creating a graph. It's about how it prepares all that information before the AI even asks a question. They call it pre-computed relational intelligence.
And this table right here shows you the key difference. The traditional way, called graph rag, is like handing the AI a messy ball of yarn and hoping it can figure out where all the threads go. It has to ask a bunch of questions, it costs a lot in tokens, and it might still miss something crucial. Git Nexus is totally different. It does the hard work up front, pre-computing the important relationships. So when the AI asks a question, it doesn't get raw data. It gets a complete, pre-structured answer all in one shot. The AI literally can't miss the context because it's already baked right into the response.
And this is how it does it. It's a 6-step pipeline. It starts simple, just mapping out the file and folder structure. Then it gets serious, using a parser called treesitter to pull out every single function and class. From there, the real magic happens. It resolves all the imports and function calls, figures out which bits of code belong together, and even traces how data flows through the app. And the final step is to build super fast search indexes so all this knowledge available instantly.
Okay, so this sounds awesome, but how do you actually get your hands on it? Well, there are two main ways you can use all this power, and it really just depends on what you're trying to do.
So you've got two flavors here. On one side, there's the web UI. You don't have to install anything, it just runs in your browser. It's perfect for quickly exploring a new project or just doing a quick one-off analysis. But then you have the CLI. This is the real powerhouse for your day-to-day work. You install it, it indexes your full repos locally, and it hooks directly into your AI agents, giving them some serious superpowers.
And when you use the CLI, your AI agent gets this whole new toolkit. We're talking 7 new commands. It can run a smart search across the whole code base, get a complete 360-degree view of any function, or even handle a complex multi-file rename with one command. But the real game changer here is that impact tool. It can actually do a blast radius analysis to predict what will break before you even make a change.
And here's what that looks like in practice. The agent runs the impact command on the user service, and boom, it gets back this perfect, structured report. It says, hey, at depth 1, handle login and handle register will break. I'm 90% sure. And at depth 2, the auth router is probably going to be affected too. This is the exact piece of missing intelligence that stops those disasters from happening.
So let's zoom out. We've seen the what and the how, but what does this all mean for the future of writing software? Why is this kind of pre-computed code intelligence such a massive deal?
Well, it really boils down to this one powerful idea, model democratization. And what that means is making these kinds of super advanced capabilities accessible to everyone, not just those with the biggest, most expensive AI models.
So there are 3 huge takeaways here. First, you get way more reliability. The AI can't miss the context. Second, you save a ton on tokens. No more back and forth asking questions. And third, and this is the big one, you get democratization. Because Git Nexus does all the heavy lifting of understanding the code, you can use smaller, faster, cheaper models and still get the same kind of amazing results you'd expect from the giant Goliath models.
And that brings us right back to where we started, this idea of building Git for agent context. It's such a powerful way to think about it, and it leaves us with a really fascinating question to ponder. What happens next? What becomes possible when our AI tools finally understand our code just as deeply as Git understands its history?